So I need to see this because this is how I make sure that I get the problems right every time. And it doesn't take that much more work. And so I know, one, if the inverse tangent of a half is equal to theta, then I can come over here and I can say that the tangent of theta is equal to a half. And I'm not really looking for the angle, pi over 4, pi over, those aren't what I'm looking for. I'm looking for the values. And so what I now do is I go to the triangle immediately. And I know the inverse tangent is defined in quadrant 1 and quadrant 4. Because it's positive, it will be in quadrant 1. So I come over here and I draw my triangle. I know theta is always the angle between the x-axis and the terminal side. I know the tangent is opposite over adjacent. So the opposite is the vertical side, the adjacent is the horizontal side, and you are looking for the hypotenuse. And I find that by doing Pythagorean's theorem. So I come over here and I say c squared is equal to 1 squared plus 2 squared. So c squared is equal to 5. So c is equal to plus or minus the square root of 5. But because you're looking for a hypotenuse, that's a distance, it's always positive. Now I come back and I can answer the problem. And I say, the problem is the secant of this junk here. Well, didn't you let that junk be theta? So what you're really asking for is, what is the secant of theta? Well, the secant of theta is the reciprocal to cosine. So the cosine is adjacent over hypotenuse. So this will be hypotenuse over adjacent, and I'm now done. And honestly, I don't know how to do it without getting the triangle in the right quadrant, so I get whether the values are positive or negative, and then I can see which side's missing that I need to find. And so it's not that much extra work, but anything without this tends to be a guess. And so the answers are never going to be pi over 4 or pi over 6, which many of you gave. And so you're not doing the problems right. And so, again, you do the homework. It's like, let's see how fast we can get through the homework, not how accurately we can get through the homework. And there's your problem. And so there needs to be this. Otherwise, it wouldn't be right. You know, I was telling my Algebra 2 class here, you know, I like to watch golf. And so I stink at it. But I think if I was sitting on the driving range and Tiger Woods came over and said, do this, do that, do this, I would do it because, hell, he's Tiger Woods. And he kicks ass. Well, I am not Tiger Woods on the golf course, but here, I'm like Tiger Woods. And so if I tell you how to do it, I'm showing you how I do it, why wouldn't you want to emulate that as opposed to your way of handling it, which many times is not correct? And so that's the kind of thing that I should see. And I should have seen it on every one of those problems. On every one of them, I should have seen it. Because even ones like, let's look at number 10, which you had to do. Let's just look at number 10. And you say here, the sine of the inverse cosine of a half, what does that equal? Well, I come down, step 1, let the inverse cosine of a half equal to theta. What does that tell me then? That tells me, well, then the cosine of theta is equal to a half. So I go to my unit circle of the Cartesian plane, whatever you want to call it. And I know that the cosine, the inverse cosine, is defined in quadrant 1 and in quadrant 2. Because it's positive, it's a quadrant 1 angle. So once again, I draw my triangle. Theta is always between the x-axis and the hypotenuse. I know the ratio for the cosine is adjacent over hypotenuse. I'm trying to find that distance. And when I do Pythagorean's theorem, now I come up with that is the square root of 3 over the square root of 3, correct? I believe so. Right? 2 squared is equal to 1 squared plus y squared. So 3 is equal to y squared. So you get y is equal to plus or minus the square root of 3. And on a test, I'd be looking for that. How do I know which one it is? Well, because it's quadrant 1, I know y must be positive square root of 3. And now I want to find the problem, which is the sine of this junk. And that junk was just theta. So the sine of theta is opposite over hypotenuse, which is square root of 3 over 2. And if you do the problem, even for the easy ones, if you do the same thing, when the hard ones come along and they're not unit circle angles, you have a technique of solving it, and it always works. I never get this wrong. These are easy problems. And so that's what I'd like to see. Are there any specific questions that you had? There was somebody with a lot of stars. Thanks, Steve.
41 in the first section.
41 in the first section. 41 in the first section. 41 in the first section. I could do that. I think we did one like this in class, I believe. So this is 8.1, is that right? So inverse sine of the sine of 9 pi over 8. Well, you want to say that the sine and the inverse sine cancel out and you end up with 9 pi over 8, don't you? But you need to be very, very careful, because we know the inverse sine is defined from negative pi over 2 to pi over 2. Does that make sense? So where is 9 pi over 8? Well, 9 pi over 8 is in this quadrant, isn't it? Right? This is 8 pi over 8, which is pi. Wrong way. I got the equal sign on the wrong side. So wouldn't one more be 9 pi over 8? But 9 pi over 8 is not in the correct quadrant, is it? And so what sine value has exactly the same, what sine angle is the same angle? What angle has the same sine value as 9 pi over 8? Negative pi over 8. It's got to be in the fourth quadrant, so it would be negative pi over 8 is correct, and that's the answer to this.
What do you mean? Like, how did you?
How did he get there?
Yeah.
He's swollen. Let's come over here. You ready? Let's look at the unit circle one more time. Okay. In quadrant 1 and 2, we know the sine of theta is greater than 0, correct? It's above the x-axis. In quadrants 3 and 4, we know the sine of theta here is less than 0 because it's below, correct? Are you with me? So, when I look at this, if I had this angle, pi over 6, that's radical 3 over 2 1/2, isn't it? And over here, I have 5 pi over 6, and that's negative radical 3 over 2 1/2. Don't pi over 6 and 5 pi over 6 have the same sine value? Likewise, 7 pi over 6 and 11 pi over 6 would have the same exact sine value. Are you with me?
Yeah.
Does that make sense? Okay, and so they're supplements of each other. Likewise here, 7 pi over 6 and 11 pi over 6 are supplements of each other. They add up to...
What? What was the question? Say it again.
Supplements add up to 180. Isn't this 180 down here? So the two here essentially are supplements, although the angles are greater than 180. But so it's pi over 6 and 5 pi over 6. So when you look over here, if I had this, I'll do it in, I don't know, green. 7 pi over 6 and 11 pi over 6 have the same exact sine angles, correct? So 9 pi over 8, isn't that exactly the same as what angle over here? Well, forget about the negative. That's going in the wrong direction, but 13 pi over 8? Well, if you went around, all the way up to here would be, hold on, all the way up to pi over 8. This is 8 pi over 8, correct? So this is 16 pi over 8, right?
17 pi.
So it's got to be 15 pi over 8, right? This is 16 pi over 8. So this is the same as 15 pi over 8, and they have the same answer, correct? But I can't talk about 15 pi over 8. It's way too big. So we could get a coterminal angle by subtracting 2 pi from this. So if you say 15 pi over 8 minus 16 pi over 8, you end up with negative pi over 8, and that would be it. So the idea is that you can't talk about the angles in quadrant 2 and 3. So you need to find their angles over in the quadrants 1 or 4 that are the same. 15 pi over 8 does work, but it's not between negative pi over 2 and pi over 2. So what's another name for 15 pi over 8? Negative pi over 8. And so those are not that easy, but they're not overly difficult.
It's the same first section.
Same section?
Yeah.
Oh, I don't know. $57. Who would give that one? That one was hard. What does it say to do? Find the inverse function. Okay, so I have f of x is equal to negative tangent of x plus 1 minus 3 and I know negative 1 minus pi over 2 is less than x, which is less than pi over 2 minus 1. Okay, so. All right, so the first step is I am going to replace f of x with y. And I get y is equal to the negative tangent of x plus 1 minus 3. And then I'm going to switch the x's and the y's. So I get x is equal to negative tangent of y plus 1 minus 3. I want to solve for the y.
You got a pen?
A pen.
Yeah. What was this kid doing?
Do I have a pen?
Because supposedly, is it next door? Doesn't supposedly. Doesn't like people using pencils. I don't get it.
Okay. Whatever. So I need to solve. He's killing me. I need to solve for the y. So what do? I add 3 to both sides. So that gives me x plus 3 is equal to negative tangent of y plus 1.
Why do you switch the x minus?
Because I'm finding the inverse. I could divide by that negative, and I get negative x minus 3 is equal to the tangent of y plus 1. How do you get rid of a tangent? Arc tangent or inverse tangent, correct? So I'm going to have the arc or inverse tangent of x minus 3 is equal to the inverse tangent of the tangent of y plus 1, because isn't it true, whatever I do to one side, I have to do to the other? What do you know about the inverse tangent of the tangent?
They cancel.
They cancel out. So I now have the inverse tangent of, this is negative x, sorry. Negative x minus 3 is equal to y plus 1. Coming back up over here, I subtract 1, and I get the inverse tangent of negative x minus 3 minus 1 is equal to y. And then the last step would be to write that as is equal to f inverse of x. What do you think? Did they leave it like that in the back? Let's hope so. What section was this? Page 614. I'm hoping they leave it like that. 614. 794. 711. 614. What number are we doing? 57. Yes and no. Okay. So we need to know this. We need to know about even and odd functions. And so the tangent, just so you know, I'm going to graph the tangent.
Odd.
And it's odd, as Jerry said. So the tangent of x is odd. What does that mean?
Origin.
It means the opposite of f of x is equal to f. Well, I like writing it the other way, actually. F of negative x is equal to the opposite of f of x. So what we have here, if you just look, is we have get confused. We have the inverse tangent. Better yet, let's go right that's fine. Inverse tangent of negative x minus 3, correct? If this is a negative, I factor out the negative, this is the same as the opposite of the inverse tangent of x plus 3. So therefore, using that property, this final answer would be the opposite of the inverse tangent of x plus 3 minus 1 is equal to the inverse of f of x. Same idea. You just got to recognize that these two things are the same because the tangent is an odd function. But other than that, it's the same. Any others? Yes? No? Camille? Delane? Giancarlo? Crystal? You just guessing just to watch me do problems? I think that for I am.
No, yeah, do that one,
Which one do you want? On which page?
On
The first section or the second section?
The second one.
The first or the second?
All right, let's go with the first one.
And I don't care, one way or the other. It's all the same to me. 61. 4. Inverse sine of x is equal to pi. What I want to do is isolate the inverse trig function. So I'm going to divide by 4. So that gives me the inverse sine of x is equal to pi over 4. Remember, the inverse sine is defined as
Power 2.
from negative pi over 2 to pi over 2, correct?
Yes.
Yes, you're right. Okay, so the inverse sine of x equals pi over 4. What you're really saying is that the sine of pi over 4 equals x. So what is x? Where is the sine? What is the sine of pi over 4? Square root of 2 over 2. So square root of 2 over 2 is equal to x.
We didn't even do that one.
I don't know. He's just doing whatever he said.
Every other
to do.
odd.
Yeah, every other odd. So he did 60.
Oh, you did 60? Oh, okay. Next
Do you need 61 on the other section too?
Yeah.
You know, Giancarlo, when everyone's zigging, Giancarlo's zigging.
Yes, sir.
Yes, sir, Ray Bob. 61 on 8.2. 61 on 8.2. Where the sine of the inverse secant of u.
Oh.
Write each trigonometric expression as an algebraic expression in terms of u. Well, I don't really like the secant much, but I know that 1, let the inverse secant of u equal theta. Therefore, I know the secant of theta is equal to u. Therefore, I know the cosine of theta is equal to 1 over u. And now I can go to my triangles. Where is the inverse cosine defined? From 0 to pi. Let's assume u is positive. Do they say that? Use a calculator to find wrong problem, right? They don't say it. But I'm going to assume it's positive to make life easy. So here's theta. The cosine is opposite. Sorry, idiot. The cosine is adjacent over hypotenuse. I need to find that value of y. That's what I'm looking for. So I'm going to use Pythagorean's theorem. And I know that 1 squared plus u squared, 1 squared, I'll get it right, 1 squared plus y squared is equal to u squared. So y squared is u squared minus 1, correct? Taking the square root, y is equal to plus or minus the square root of u squared minus 1. If we are talking about quadrant 1 or even quadrant 2, I know that y is positive there. And now I want to find the sine of this junk. Well, that junk you let be theta. So what is the sine of theta? It is opposite over hypotenuse. Well, the opposite is the square root of u squared minus 1 over the hypotenuse, which is u. And there's your answer. Again, I find it difficult to do, next to impossible, without the triangle. I wouldn't know where to go. Honestly, I wouldn't know where to go. And I've been doing it a long time, and I always write the triangle. It's like once I get the triangle, I'm like, oh, okay, I can do Pythagorean's theorem. Oh, now it's just a normal trig function, opposite over hypotenuse, or whatever we're talking about. And so it really clarifies the issue for me. And it might take you all of another 15 seconds, and it's the difference between right answers and wrong. And I don't know about you, but I like to get them right. You're a little strange. You eat, only the middle of the pot. All right, let's start with A3.
Besides the bread.
Can you? Should we let you?
Yeah.
See what happens when you drink all that lemonade? Okay, we're going to start solving the trig equation. This is fun. Big fun from now. Huge fun from now. Okay, so we're going to start solving trig equations. I don't want you using your calculator.
Your calculator.
That's what I said, calculator. Only cool people say calculator. Cool people like us say calculator. You ready?
Yeah.
What is this? What section? 8.3, right?
Can you just put it in the guard here?
No, I will.
Yeah, right.
So this,
As soon as I turn around, you're going to toss it.
No, I'm actually gonna start writing and. Solving.
Did I ask you, Ray, did you go to the site? Is it on there? Can you get there?
Yeah, but you didn't put the
You
new
get it to the last bit.
8.1, 8.2. The others were
only the section.
Did you ever upload it?
You had,
Oh, look.
yeah, 7.5 and 7.7 due, and then the first one we did before.
So last class wasn't on there? Did I save it?
Yeah, I think you.
Yeah, you did, and then you were trying to up 50 with
Is it on there now? Did you see it today? I'll look. I think I did upload it. I don't know. Anyway, okay, solving trig equations. This is not hard. It's the same game. And so it starts off real simple. And they want to know, is a certain value a solution to a certain equation? For instance, that too. Is theta equals pi over 4 a solution to 2 sine theta minus 1 equals 0. Sorry. Is that a solution? And so what we're going to do is plug pi over 4 in for theta. And if I end up with a true statement, then yes. If I end up with a false statement, then no. So I get 2 times the sine of pi over 4 minus 1. Does that equal 0? Well, what is the sine of pi over 4? So this is 2 times the square root of 2 over 2 minus 1. Does that equal 0? Well, the 2's cancel out, and does the square root of 2 minus 1 equal 0? No, so it's not a solution. If I try, let's try this one. What about is theta equal to 7 pi over 6? A solution. Well, we do the same thing. 2 times the sine of 7 pi over 6 minus 1. Does that equal 0? And what is the sine of 7 pi over 6? Negative a half. So 2 times negative a half minus, I think I should have done 5 pi over 6. Let's do 5 pi over 6. Then what is the sign of 5 pi over 6? Positive a half, and we get 1 minus 1 equals 0. Yes, it is a solution, sorry. You get that? So, I mean, it's like anything else. How you know something's a solution? You can graph it, and if the point lands on your graph, it's a solution. If you solve it and get a true statement, it's a solution. You with me, Kamel? You all right? Cheer up, honey. It's all right. It's just trigonometry. The trigonometry gods won't be happy with you if you don't cheer up. Let's solve the easiest ones. The cosine of theta equals a half. What you're asking is, where on the unit circle is the cosine a half?
No, it's not. Pi over 3.
So theta is equal to pi over 3. Is there anywhere else?
Yes, 5 pi over 3.
And 5 pi over 3. What?
You know the second one?
There's usually more than one answer. Okay. What happens if I say find 8 solutions? So let's go to the unit circle. That's almost perfect. Stop. Close your mouth. The flies are getting in and the bad breath is getting out. Okay. If I start here, you need to watch this, otherwise I promise you you're going to get confused. If I start at pi over 3, the distance from pi over 3 to 5 pi over 3 is 4 pi over 3. Does that make sense? But the distance from 5 pi over 3 back up to pi over 3 is only 2 pi over 3, so it's not the same, is it? So what we're going to do is deal with each one individually. And I can say, if I take pi over 3 and I go around the circle one time, won't I end up at pi over 3 again?
Yes, sir.
So we could say that this is going to be theta is equal to pi over 3 plus or minus 2n pi. What does the plus mean? I'm going in the counterclockwise direction, 2 pi. What does the minus mean? I'm going in the clockwise direction, 2 pi. Won't I, if I take a full spin of 2 pi in either direction and back it pi over 3? So then what does the end represent? The number of rotations. If I go 1 time around, it's 2 pi. If I go 2 times around, it's 4 pi. 3 times around, it's 6 pi, and so on and so on. So I get theta is equal to pi over 3 plus or minus 2n pi, or theta is equal to 5 pi over 3 plus or minus 2n pi. Are you good with that? So now I want 8 solutions. I could start with pi over 3, and I could add 2 pi, and that gives me 7 pi over 3. I could add 2 pi again, and that gives me 13 pi over 3. There are 3 solutions, aren't there?
One more.
And if I say, just for kicks and giggles, add 2 pi again, that's 19 pi over 3. Don't I have 4? And then I could do the same exact thing with 5 pi over 3. Do you have to go in the positive direction? No. Could you go in the negative direction? As long as you're adding and subtracting 2 pi, you will always end up in the same spot. So I could have 5 pi over 3 plus 2 pi, which is 11 pi over 3. Plus 2 pi is 17 pi over 3. Plus 2 pi is 23 pi over 3. That's 1, 2, 3, 4. There it is. There's 8 different solutions. Do you get that? Yes or no? You can get any of it down or no? Oh, right. I understand that.
Nick, when you do a full circle, it's
Isn't it cool? You see his top? See his top? See his top?
That was cool.
when you do a full circle.
Doesn't work. Is there a- I got you.
You good? That was hysterical, let me tell you.
Look. Read it and weep, old man. Look. Yeah, rocked.
Is that what the other one? Is that what you did with the other one?
Yeah, I can't do it.
Okay, now I only want all the answers within one rotation of the unit circle. Now I only want one rotation. So what I need to do is isolate the trig function. So what would you do to isolate the trig function first? Subtract square root of 3. So I get 2 sine of theta is equal to negative square root of 3. Now what would you do? Divide by 2. So I get the sine of theta is equal to negative square root of 3 over 2. So what is theta? Where on the unit circle between 0 and 2 pi is the sine negative square root of 3? 4 pi over 3.
That's imaginary.
And where else?
5 pi over.
And 5 pi over 3. And those are all my answers. Because now I was only looking for the solutions in that interval. Okay? And that's not imaginary. It would be imaginary if the negative was inside the radical or underneath the radical.
Oh.
This is saying take the square root of 3 and then multiply by the negative.
Okay. Sorry, master.
You're welcome. It's okay. If I'm your master, you must be the slave.
Maybe you're like the master slave.
Okay. If you don't follow, this will confuse you.
Okay.
Now we are solving what's called double angles. It's not 1 theta, it's 2 theta, or a half a theta, or 10 theta. And what we're going to do is pretend. We're going to make believe. And what are we going to make believe? We're going to make believe that the problem was not the sine of 2 theta equals a half, but that the sine of theta equals a half. And so where on the unit circle is the sine of theta equal to a half? Pi over 6. So theta is equal to pi over 6 plus or minus 2n pi. Where else?
5 pi over 6.
5 pi over 6 plus or minus 2n pi. Now, do you see how we're going from 0 to 2 pi? That is a counterclockwise rotation, so I don't really need the plus or minus. I just need the pluses because I am only going from 0 to 2 pi. And what we're going to do is come back to reality. And the reality of the situation is that it was not the sine of theta, it was the sine of 2 theta. So I take these answers, and instead of them being equal to theta, I now set them equal to 2 theta. So I have 2 theta is equal to pi over 6 plus 2n pi, or 2 theta is equal to 5 pi over 6 plus 2n pi. But you don't want 2 theta, you want 1 theta. So how do I get rid of the 2? Divide by 2. But you see how there's a fraction here? So instead of dividing, I'm going to multiply by half. And I multiply everything by a half. And so this now gives me theta is equal to pi over 12 plus n pi, correct? And this now gives me theta is equal to 5 pi over 12 plus n pi. But I only want the answers between 0 and 2 pi. So I need to take my answers and add pi to them until I get a number that's out of range. So I'm going to start with pi over 12. Pi over 12 plus pi, which is really...
I end pi. I hate the end of the pi because the end looks like the pi.
So this is really 13 pi over 12. Is that less than 2 pi? Yes, so that works. If I add another 2 pi to that, another pi, which is 12 pi over 12, I get 25 pi over 12, and that one's too big. So I have pi over 12, and I have 13 pi over 12. Now let's do it with the 5 pi over 12. I say 5 pi over 12 plus 12 pi over 12 is 17 pi over 12. That one works, doesn't it?
The next one won't work.
The next one won't work. So I have 4 answers. So my answers are theta is equal to pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And those are the answers to the problem. So if you handle it like you did if it was a single angle, get those answers and set them equal to the double angle, you then can find out all your answers. This works whether it's 2 theta, 3 theta, half a theta, 10 theta, always works. And so you can get a pretty long list of answers, and you got to keep checking them until you get one that's out of range, and then you stop. Questions? Either I'm doing a great job or you just don't care.
Yeah, take it down.
No.
Dr. Howell's doing such a great job.
Okay, good question. Okay, so you know how like send us like the audio recording? You also see it logged in as a parent, or you logged into student?
I don't know. All I know is I'm putting it in to the collaboration site from the from my teacher portal. And when you do the student portal, what comes up is your schedule. What do your parents see when they pull it up?
It's not that, it's that.
Give me your password.
Yeah.
Reset
You
your
don't know
password?
your password?
Yeah, reset it. Do you know the security question answers? Okay.
You should then talk to someone here at the school. I would start with Miss Sign.
They go and put in like what's it called, a heat ticket or something like that to the day school, and then reset it for every time.
Who'd you talk to?
Hey, Mary.
And he was able to do it for you?
Oh,
I can't hear you.
Yeah, it doesn't make
I know who he is.
but I mean, I'm just he needed us to use it, so he said
How did he reset it?
he said.
Oh, I can send in a heat ticket for you. Is that what you need to be done?
Where?
Yes.
Yeah.
Classroom, you said.
Like you need it has his ID number and everything, and then they reset it.
If you wait 2 minutes after class, I'll send in a heat ticket for you. Okay, questions? Jerry, you having a good time today?
Yeah.
It's all important that you have a good time today, Jerry.
I'm actually writing down everything you do, so
Dr. Hannah's
I'll press that.
Excuse me?
Well, in the audio.
Okay. Would you, right, so we see where it says pi over 12 plus pi? Why you start writing it by pi with?
Because it's, if you go back here, remember what I said? If I want all the solutions, if I start here at pi over 3, as long as I'm adding 2 pi or subtracting 2 pi, I end up back at pi over 3. It's the same idea with the pi over 6 angles and the sines and the cosines. So when you come back over here, oops, sorry, you are, I don't know how that thing got there, but anyway, this is a double angle, correct? And so I'm going to solve it like it's a single angle, and I get pi over 6. Because of the sine and cosine, I know it repeats itself every 2 pi. So there's where the plus 2n pi comes from. So in other words, pi over 6 plus 2 pi is 13 pi over 6. You're still at pi over 6, right? And so, but we weren't it wasn't a single angle. It was really a double angle. So I took all those answers and set them equal to 2 theta. And I divide by 2, there's where the 2's cancel out, now it's n pi. So when I come down here and I got pi over 12, if I want another angle, I got to add pi to that. And that would give me another place where I would have the same solution. Good.
But you wouldn't have known that. How did you do that?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. David comes up with my grade book. Yeah. Yeah, but they said it says college algebra. So I should take all the grades and put them in there. So I'll
Like,
print out their grade
whatever it's
and
saying,
put them in.
and nobody laughs.
Okay. It's not a problem.
Yeah.
All right. Okay, that was, I don't know who that was.
Martinez?
No.
Probably hang on.
But they're creating a new code because apparently trigonometry doesn't show up.
Yeah.
Right, so they're creating a new code. And all the grades that I've been putting in, because they collapsed all of the things, I guess I've been putting them in college algebra. And so now there'll be a new code. So you need to make sure next class that you remind me, so I'll print out all your grades.
Oh, yeah. Print out my episode.
Okay,
They don't go in, they're going in as Z's.
Oh, never mind.
And so then we can put it in, and then that should now show up on the student portal as trigonometry. And I'll take all of those files again, and I'll put them back into trigonometry like where they're supposed to be.
stop the last test.
You don't have to. You don't have to put in the other things we know they're there.
I'm talking about all the video.
Oh, yeah. Oh, there's a...
Yeah, now when they create the new code in your student portals, trigonometry should show up.
You don't have to upload them to the other ones though. We know they're there. We know they're in college algebra.
Trigonometry shows up online, so maybe the company can
That's what she just said. I don't know.
Well, there's something wrong with the on
It's not on everyone else's stuff.
Yeah, wasn't she the only one in the role or something?
Yeah.
Oh, okay. That's fine.
He's special. Special. And then they
I
got
got a
to
question
sing
about the
it.
word.
What you got?
What if the 2 never cancels out like the 1 and 2 and like?
You would have to, if it was a 3, you'd multiply by a third to get it to cancel out.
Oh, you have to.
Yeah, you got to get rid of it.
Oh, okay.
So let's say it was stayed over 2, then you would multiply everything by 2 to get rid of it.
No, not 3 theta. The 2 and pi.
Oh, well then it would be whatever it is.
But what does the 2 do to the thing?
Because 2
Okay, the 2 pi, forget about the n. The 2 pi, what that means is if you start at 5 pi over 3 and you go 1 full rotation, which is 2 pi, you'll end up in the same spot, and therefore you'll have the same sine, cosine values. 2 pi, right. The n just represents how many times I'm actually doing it.
No, but in that one, the 2 got canceled out, so you only did it by adding pi.
Right,
So that's
exactly.
what
And so if it didn't cancel out, then it might be every 4 pi, but it'll never be more than 2 pi. It can't be more than 2 pi because you follow what I'm saying?
Yeah.
So it's always going to be a fraction of. Where are you going? Oh, you're not going to get the homework.
Oh, no.
I expect it to be done still on Tuesday. Hey,
No, it's
just
not Tuesday.
Follow
It is
the
a Tuesday.
follow the syllabus, and it'll be due.
Yeah, you're going to put the notes on for sure, right?
Yeah, it'll be due the Tuesday we come back.
Okay.
What was that?
Okay.
Oh, yeah? No,
All right.
it's one side.
Let's do this one. Don't mean nothing. Tangent of theta minus pi over 2 is equal to 1, and I want this from 0 is less than or equal to theta is less than 2 pi. How to do that? I don't know. I'm going to do it a little differently than the book.
Okay.
We did the complementary functions. Does that make sense? They call them co-function identities. And we know that the tangent of pi over 2 minus theta is equal to the cotangent of theta. So therefore, I know the opposite, therefore, but that's not what I have here. What I have is the tangent of theta minus pi over 2. What is that equal to? Well, the tangent is an odd function, so I know this is equal to negative the tangent of pi over 2 minus theta. These are equal because this is an odd function. And therefore, I know negative the tangent of pi over 2 minus theta is equal to negative the cotangent of theta. And I'm going to replace that with negative the cotangent of theta. And so now I get negative the cotangent of theta is equal to 1. I want to isolate the cotangent, so I get the cotangent of theta is equal to negative 1. I told you I never think about cotangents, I think about tangents. So if the cotangent of theta is negative 1, what's the tangent of theta? 1 over negative 1, which is still negative 1. And where is the tangent? Negative 1. It's negative 1 here and here. 3 pi over 4 and 7 pi over 4. And those are my answers.
I got line on wrong. I don't know why.
So I use the idea of, I know two identities. I know the cofunction identity. In other words, what you find is the complementary angle. Isn't pi over 2 90 degrees? Don't you find a complement by subtracting your angle from 90 degrees? So we know that the tangent of pi over 2 minus theta is equal to the cotangent of theta. That is a cofunction identity. Oh, spell calculator the same way. But that's not what I had. I had the opposite of that. And I know because the tangent is odd that the tangent of negative x is equal to the negative tangent of x. So that gets me here. And I know that that's the cotangent multiplied by a negative. So everywhere I see the tangent of theta minus pi over 2, I replaced it with the negative cotangent of theta. And then I was able to solve the problem. The book does something a little differently. They say because the tangent repeats itself every pi over 2 units, and they said this. I find it more difficult. You can look at what they do. Whatever you like better, you can follow. The other next couple of problems, you need to use your calculator, so I'm assuming you know how to use your calculator. So I'd like to do ones that are not calculator intensive, because that's what I like. No calculators. And we're going to start factoring. Don't you love factoring, Kylie?
No.
Kylie's favorite thing is factoring. And so we're going to factor trig equations.
Foil.
Foil's multiplication. We're going to factor going the other way, the other F word.
Right.
I heard Nick was excited. Nick, are you excited? Absolutely, he says. Nick, it's all right, Nick. There is somebody out there that loves you, so don't worry. Do you know how to factor? I'm going to do this one time to make it easy, and after that I'm just going to use the trig functions because you'll see the pattern. We could do something called U substitution. I don't know if it makes it easier or harder, but you'll see it without the trig function so you can handle this. So what I do is I go to the middle function and I say, let's let U equal the sine of theta. Better yet, let's do this. Let's go the other way. Let's let the sine of theta equal U. Then what would sine squared theta be? U squared. And now I'm going to substitute that in. Everywhere I see a sine squared of theta, I'm going to replace it with U squared. So I now have 2U squared minus everywhere I see a sine of theta, I replace it with U. So minus 3U plus 1 equals 0. I will show you how I factor. It's not the only way to factor. But you have to be able to factor, Neres. I mean, there's no way around this, okay? And so the only way to do this is I break up the 1 and 2. I break up the 2 into its factors of 1 or 2. So the only way, therefore, 2 parentheses, to break up 2u squared would be 1u and 2u. Are you with me? Yes? Okay. The sign between the middle term and the constant is positive. What does that tell me about the signs in my parentheses? That they will be the same. Well, if they're the same, they could both be positive, or they could both be negative. So I go to the middle term, and since the middle term is negative, both of these will be negative. The only way to break up 1 is 1 and 1. So I get 1 and I get 1 equals 0. You must check the middle term. How do I check the middle term? Outer plus inner. So the outer is negative u, The inner is negative 2u. That's negative 3u. That's exactly what I wanted, so this works. Are you with me? Now I'm going to solve each piece. So I get u minus 1 equals 0, or 2u minus 1 equals 0. Adding 1 to both sides, I get u equals 1, or adding 1 and dividing by 2, I get u equals a half. Have I lost you yet?
No.
Okay, so now what we need to do is what we call back.
Wait, then you add the inner and outer?
Yes, yes, I check. First, outer, inner, last. I don't ever have to check the first, Jerry, because I know u times 2u is 2u squared. I don't need to check the last, because negative 1 times negative 1 is positive 1. So now I'm just checking the middle terms.
So the outer and the inner.
So I do that by outer. U times negative 1 is negative u. Okay. What do I mean by back substitution? You're going to go back and you let the sine of theta equal u. So now everywhere you see a u, you're going to go back and replace it with the sine of theta. So I now have the sine of theta equals 1, or the sine of theta equals a half. Where on the unit circle is the sine of theta equal to 1? Pi over 2. So theta is equal to pi over 2. Or where on the unit circle is the sine of theta equal to a half? Pi over 6 and 5 pi over 6. And those are my answers. It's getting harder. It's not bad, but you got to know your algebra, see? And that's what makes this hard, is I'm asking you to recall things that you did last year or the year before. You need to bring them back. You need to know how to factor. You need to know your stuff. Otherwise, these are going to get ugly. And I can't help that. It's not pretty like us, I guess.
Say Nick.
Well,
Nick.
I think this is
First time was
You're off today.
You don't think Nick's pretty?
No, but you always make fun of him, and now you compliment him. What's happening? What's wrong?
He's always
the shirt.
Oh, it's the shirt. Because you guys are wearing green. Oh.
Green and red goes good together. So it's always Christmas around you, huh? Last one I'm going to do today. Maybe not the last one. Close to the last one. What did you say?
His hair's orange.
Okay. This one is the hardest one yet. And the reason is I always think about polynomial functions. In the sense that, how do I solve a polynomial function? I set it equal to 0. So that's going to be my first step. And so I'm going to have 3 cosine of theta plus 3 minus 2 sine squared of theta equals 0. Now that it's equal to 0, I want to try and factor. The problem is I cannot factor it because I have a cosine of theta in this term and I have a sine squared theta with this term. So I have to use an identity to change the sine squared to cosines. And so what identity am I going to use? Pythagorean's identity. And we talked about them. What is Pythagorean's identity with the sine squared? Sine squared of theta plus cosine squared of theta equals 1. So I want to solve for the sine squared of theta. So I'm going to subtract cosine squared of theta from both sides. So I get sine squared of theta is equal to 1 minus the cosine squared of theta. And everywhere I see a sine squared of theta, I'm now going to replace it with 1 minus the cosine squared of theta. So coming down, I get 3 cosine of theta plus 3. What am I doing to the sine squared of theta here? I'm multiplying it by negative 2. So I need to now multiply this binomial by negative 2 because this is 2 terms. How do we multiply binomials? Parentheses, very good. Very good, people. So that's minus 2 times 1 minus cosine squared of theta is equal to 0. Are you good? Are you okay? You good? Marinating? Okay. We multiply through the parentheses, so I get 3 cosine of theta plus 3. Negative 2 times 1 is negative 2. And negative 2 times negative cosine squared of theta is plus 2 cosine squared of theta, and that equals 0. Now I have a quadratic. They all have the same trig functions, so I can factor it. But before I factor it, I want to combine like terms and put it in descending order. So I'm going to combine the like terms here, and I'm going to start in descending order. So I get 2 cosine squared of theta plus 3 cosine of theta plus 1 is equal to 0. And now I'm going to factor again. I come down to 2 parentheses. I'm not going to use U substitution here. But I do know the only way to break up 2 is 1 and 2. So therefore, the only way to break up 2 cosine squared theta would be 1 cosine theta and 2 cosine theta. The sign between the middle term and the constant is positive. That tells me the signs inside the parentheses are the same. So here they'll both be positive because the middle term was positive, and the only way to break up 1 is 1 and 1. I told you we need to check the middle term. So that gives me cosine of theta plus 2 cosine of theta. Isn't that 3 cosine theta? So I'm going to go to another page, and we have here cosine of theta plus 1 equals 0, or 2 cosine of theta plus 1 equals 0. So I subtract 1, I get the cosine of theta equals negative 1. Where on the unit circle is the cosine of theta equal to negative 1? Pi. So theta is equal to pi. Or, here I subtract 1 and divide by 2, so I get the cosine of theta is equal to negative 1/2. Where on the unit circle is the cosine of theta negative 1/2? 2 pi over 3 is correct. And 4 pi over 3. So you got to know the unit circle. And there are your answers. Boy, that is a lot. What do you think?
That wasn't bad, not gonna lie. Did everything I lost
I have more, but I don't want to cram it down your throat in 2 seconds. So, we did all the way up to example 9. We did example 8. So, in the homework, do those kind of examples that you see. And I'll tell you where they are. They're basically, you could probably do all the problems up through like 80 in that range, 77 in that range. And so do whatever the syllabus says. Do the odd problems there, you know, and that will be due Tuesday when I see you. And
I'll
no,
Don't have a good spring break anyway.
oh, have a good spring break. Yeah.
What page is it?
What page is it?
Okay, wait a second.
628. Start at 11. So go 11 through, let's say, 75, the odds. 77. 35.
No.
We will have another test before the end of this marking period.